Hey, Shashank. Okay, can you hear me? I'm audible, right?
Yeah, you are audible.
Okay, thank you. Okay, so as we were discussing Chubby for a couple of sessions, so I think this will be the last one. In today, we will be discussing about caching and some other section which are, I think, database and backup and all that. So, but I think caching is the only most important section what is remaining here. So now in caching, so why is caching required? Because in Chubby, we know that we write very less, but we read more because more of a configuration is a sort of a database where we just want to have the information, and it's modified very less number of times, but it's read in a lot. So therefore, you have a huge read requests, then a writes, and it makes sense therefore to cache. So it helps read requests and it scales. And also in Chubby, we know that the replicas don't support reading. So it all happens with them from the master. So if you keep on hitting the master for all the read requests, also the write requests, then it's going to be a problem. So therefore, the way Chubby has been designed is they have, delegated all the caching to the client side. And but even though it is delegated to the client side, the caching and still the caching is also uh, is maintained, in the sense it's more of a strict consistency at the caching side also, and it is done by using invalidation events from the master and using a lease mechanism. So the things what can be cached in a client side are the file data, then something of the nodes metadata, and all the open handles information and all that stuff. So let us go through the flow of how, or maybe the way it is actually done, and the invalidation is done in this Chubby. So because that is important, right? So the caching, it caches at the client side, that is perfectly fine. It caches all these three items, and I think it also does for the logs. So everything is cached, but then what happens if we have to modify anything in the um, if we get a request to modify already existing file? So in that case, that file is opened by many other clients, and so how that is, that consistency is still maintained using so many of clients opening a similar file, the same file, and we only have a master which we have to communicate with always. So how that is done? So they follow a particular protocol. Here it's called as invalidation protocol, and I just got this diagram from some other site, and it helps us to actually go through it and understand how it happens. So if you look here in this diagram, we have a Chubby cell. We have one leader, which is in color black, and then it has 4 replicas. Okay, so that is what a Chubby cell usually is, made of 5 nodes, which one will be always be leader, and we are always hitting, all the clients are always hitting the master or the leader, and then it keeps on writing or reading to that. So, but if we are caching at the client side, now these are the 3 clients which are actually talking with this mass leader. And here, if you look at the client, okay, let me mark it. Okay, so if this is client 1, okay, and this is client 2, and so this is the client 3. And here, what it says is, this client 3 is saying that I want to change the file content of whatever this file is, some ls empire tags. Okay, so the ls for the logging service empire might be the current Chubby cell name, and this might be the text, whatever that file he wants to change. So then he sends this request on this red arrow here. Okay, so this is the first one, and it says here also, if you look at the color code of the arrows, they have mentioned all the information here. So it actually requests for changing some of the content in the X. So now here, so this master, when it receives, it won't immediately modify the file content in the master. Okay, so but then it just blocks that particular request. But what it does after that is actually the master will send an invalidation request to all the clients which are holding this file. And how it does that, because the master has the list of all the clients which are holding or caching this particular information, and that is the reason it knows about it, and then it sends invalidation request to each and every client. Okay, so this is what the green arrow represents here. Okay, so it is sending a invalidation request to all of these clients, and that also is done by piggybacking on the keep alive RPC. So all this communication happen in RPCs with the keep alive RPCs. So whenever because the leader will always hold the keep alive RPC, and whenever it has information, it will immediately send, or if the lease is about to expire, it will release a keep alive request, right? So in this case, it will immediately send when it receives that it has to modify. So information, so it will on piggybacking on the keep alive, it will send that information to the client. So whenever the client receives that request, so what it will first do is it will flush whatever the contents it has for that particular cache, and then it will send an acknowledgement to the master with this orange arrow here. So both of the clients will do. So this leader will wait for all the acknowledgements from all of these clients. Okay. So when it receives all the acknowledgements, then only actually it will proceed. But in some cases, you might say that what happens if a client dies down? So at that time, it will actually wait for the lease to expire. Okay, so therefore, whenever we see in this caching for this client side of Chubby, it says it is done by the invalidation events invalidation and with the lease mechanism. So both of them are very important here. So either it receives acknowledgement, or if it doesn't receive acknowledgement, if the lease expires. So it waits for the lease to expire. When the lease is expired, then this particular client becomes uncacheable. Okay. So then when it receives that, then the leader will again send a request to all its replicas. So if you see this pink arrow, so it is sending the links to all these replicas, and it will ask them to replicate the change. Okay. So once that is done,
one question here. Say if multiple clients are not, I mean, they're not connected, but the lease times will not be same for all the clients, right? So at that time, does the leader wait for all the clients to expire the lease?
So if the multiple clients are not connected, then they won't have a lease. If a client is connected, then only it's going to have a lease, because you have to have a communication.
I mean to say now you explained one case where the client lease has expired. So which case the lease will the leader will wait for the client lease to expire?
Yeah. So if it doesn't receive an acknowledgement, right? So because if it doesn't receive an acknowledgement, then it will assume that it has expired. So that whatever you have the lease expiry, the lease mechanism in the client side. I'll just take to the back. There's a diagram here. So if you see here, so this lease of C 1 year, right? So you have a corresponding lease at the master side also. So if this master actually expires, then it will assume that this lease also has expired. So if there is no communication from this client, so you always have a corresponding lease which you have at the client side at the master also, and because the master actually dictates the leases.
Okay, so here, if multiple clients are not able to send the new lease request, like what are the says one, right? So does the master wait for all the clients to expire the lease?
Yeah.
So that will be used, right? The delay.
Yeah. So it because everyone will have the similar lease. The master will almost have the similar lease, right? So it cannot have more. But yeah, as you say, there will be some delay in that, and that is always there, because all these because you have to do it for in the case for leader election.
Yeah.
So it is a time consuming job for sure.
Yeah, got it. Yeah.
Yeah, that is a downside, but you have to do that for maintaining that strict consistency. Yeah. So that
or max of lease time it might, I mean, whatever the maximum of lease time of all the client, right? Till that extent, your master might wait.
Yeah.
Something like.
Yeah. So let me remove this. Okay. So then when it receives, then it actually updates all the Chubby replicas also. And when it is updated, then it will send an acknowledgement to the client. So whenever the client gets an acknowledgement that from the master that whatever what the client wanted to update, so it assumes that all the replicas as well as all the clients have the same data. So it's completely strict consistency. Okay, when it flashes in these clients, it actually doesn't update it, because whenever again this client will have another read request for that particular file, that time only the cache will be updated. Okay, so that is the way it is done. So this was for the whole of this caching, and this was the flow. And also in the caching, there are a few things is so one is so whenever we are doing in addition to caching all the data about the metadata and everything, we also wait for in this time what it says that it was whenever we are actually updating at that time, you might still receive some read request from some other clients, right? Because the master is holding and for that particular file. So but at that time we don't have that cache data in the client, so the reads will be directly done from the master. So in that case, if we are reading and if that particular file is about to be modified in that master, so the Chubby doesn't delay any of the reads. If some other client is actually wants to read from that particular file, it still allows, but it doesn't reads from its local cache, the client's local cache, because it doesn't have that value. So it will again go and hit the master. So in that case, there will be a hit to the master, but that is still manageable because we don't want to stop other clients from reading it, because reading is more important here because we have more read requests, and only the master has to handle it because the replicas don't handle read in this case. Okay, so therefore it will still be handled. And also in this case, it says that even the handles are cached, correct? So handles are cached. So whenever the handle is cached, so a client actually, when it opens, it sends an open request to the master through an RPC. At that time, it will receive a handle, isn't it? And that handle will be cached in that local client. But the only slight variation is because whenever that particular client, okay, is actually sends a close request, it happens for the ephemeral nodes, right? It cannot that information also has to be flushed out. Okay, because if it receives a close request, so that close will be almost similar to the way it is updating that information. So that again will have to be done the way uh, to follow that invalidation protocol what has been followed over here. So, and also it says that whenever there is a restriction, like whenever, because whenever you have that locking information, a particular client uses it. And yeah, here it mentions about the locks are also cached, right? So the logs are cached because you want a same client, if it opens a lock, that value has to be cached because it can reuse that lock value over and over again. So the same client, but not the clients which are actually concurrently trying to access the log, but those client cannot use this log information because this won't be valid for them. Okay, but only the same client which wants to actually access this log will actually use it. So therefore the log can be cached on a client. So so that is one thing what they have discussed here. So it looks very different, but that is the way the logs also can be cached in this case. And other than that, it also opens whatever the handles the master has, it can be cached. So this is what it talks about the caching in general, right? So any questions on that, or if anyone wants to add anything here?
So seventh one, data unachievable, like, I mean, the request has to go from client to the master. right? I mean, that ACK should be received by the master, then only before invalidation we can make it, right?
Okay, so the data uncacheable until invalidation is acknowledged.
Yeah.
Okay, so the data is uncacheable here. Okay, because so whenever the master is acknowledged, right? So then only actually you can make the cache again cacheable, right?
Okay.
Because till the leader doesn't receive all the acknowledgements and it doesn't actually replicate all the data on the replicas, then when it sends this acknowledgement back, which is the blue arrow, so then it completes the whole cycle, and then only this particular cache at the client side will be cacheable. Till then it will always be uncacheable.
Got it. Yeah, makes sense.
Yeah, so then it will be cacheable here, and then also it will go and again make these other clients cacheable, but it won't have that value. Okay, but whenever it again reads, this client will read again that value, then only it will be cached for the other clients. Yeah. Okay, so this is one. Now if you look at the other stuff, they are not much actually to discuss, but something they talk about the databases. And what is said is Chubby actually earlier when they started with this, they didn't have the what current database is, but they were using the Berkeley DB database, and the Berkeley DB database was using the B trees and all the stuff. But eventually they found out that Berkeley DB exposes some risk to Chubby, and therefore they decided to write their own custom database. Okay, and what was that custom database? Was it is something very simple, like key value database. Okay, and it had a write ahead logging and also snapshotting. Okay, so we know a key value database is fine, but write ahead logging is like you keep on writing all the logs in a disk, right? And then the snapshotting is you at a certain period of time, whenever you have a certain number of write ahead logs, you just copy it to some other place. So that is what snapshotting means. Okay, so here what it talks about, all these operations are atomic. So whenever we write to key value, it will always be atomic, and there won't be any transactions required. Okay, because we just have a key and value, you write all that value in an atomic fashion. You completely write it, because that is the way the Chubby is. Whenever you want to write into a file, you completely write a file. You don't write the file in blocks. And whenever you want to read a file, you completely read the file, but you don't read the file in blocks. So therefore, always the operations are going to be atomic. So that is what it means. And the database logs are distributed among replicas. And the way it is distributed, it's using the Paxos protocol. The underlying is done by the Paxos protocol. And now in this backup, okay, so they also talk about this backup. So the backup is always done after every few hours. So whenever this write ahead logs, it completes a certain period. I think it might be configurable, and after some time, the master will take a snapshot of that whole write ahead log, and it will write into a database to some global file system, GFS file server in a different building. And why in a different building? Because it wants to survive the building damage, and it doesn't have any problems if it is in the same building and if we lose power or something like that. So therefore, to maintain that, it actually uses a cross building data replication. So, and also these backups are used for disaster recovery. So whenever there is some problem, so you want to recover the whole node, so you can always go and look back to the GFS file server and copy all the data along with so whatever the information or the write ahead log, the delta version of it is present in the current cell, right? Because what it says is whenever you're snapshotting, whenever you copy certain number of data in the write ahead log to a particular file server, you also delete that from that current master, from that current cell. So you don't have a burden on the current cell also to keep maintaining more data and consistent duplication of the data. So it just wants to, whenever a particular snapshot is done, so you remove that whatever the snapshot value is from your current write-ahead log. And the other use of this backup will be when you want to initialize or you want to, get a new replica in your cell, because you usually Chubby use only 5 replicas, 5 nodes actually. So in that case, if one of the replica fails, then if you want to take another replica, so at that time also this backup, whatever is stored in the file server, will be helpful, because it picks up all that what is snapshotted at that file server, and also the whatever the current version it has on a master. So whatever is remaining, based on that, it replicates the new replica. So that is a way it does. Now then they talk about mirroring. Okay, so mirroring is basically you are actually trying to mirror some of the files across a different Chubby cells. And so why is that done is because you want to copy some of the configuration files, okay, in various computing clusters distributed around the world, because whatever the configuration files you have in the Chubby cell, you should not lose that. So what they are saying, it has to be distributed across all over the globe. So that is the way they do it. So it that actually handles your durability, and it's more durable, so you don't lose it because you are copying it in various different geographies. So and also it somewhere it is said that this copying happens in very less time. It's very quick, it's very fast, because they are all connected always. And the reason is also the mirroring is fast because all those files are very small files. Okay, and we also have that emit mechanism using that keep alive, piggybacking, and everything. So because whenever a single file is added, modified, delete, we always generate an event, and based on that event, that data is quickly updated across all the globe. And if in case if some of the mirror remains unchanged in some of the cell in some geography, it will be restored whenever that particular mirror comes back. And they have mentioned something about this global Chubby cell. So you will have one global master, which will have all the replicas information, and then you will that will be replicated across each and every cell. So this global master, whatever the data, it will be replicated in different cells on different replicas, so you don't lose the data. So there will be cross replication of many of these replicas uh, of this global Chubby cell, so you don't lose that data. It's more durable and reliable, right? So what is actually this use for this global Chubby cell? It actually stores that own ACLs. So if you look, this data is very different. It's not the real data what we are looking for, but it's more about the ACLs. And also then whenever for some other various files they want to advertisement their presence for different services like the monitoring services, then those things have to be replicated all over the globe. And also I think this is more used in big tables, cells and all that, so that might be discussed more when we actually discuss about big tables. Okay, so now something to discuss about the scaling. And uh, frankly I'm really running through these because there is not much to discuss about it, because that for the Chubby, till the caching is only important. Rest of the things are it's just there. I just want to cover them, and it's not mentioned in details also in many places. So therefore, I'm just running through. Now, if you look at the scaling, Chubby already has some part of the scaling, right? So what are those things? One is when we, okay, before that, what it said is, they had an experiment in Google some time back, and they said a particular Chubby master can handle around about 90,000 clients, and it's still stable. So that many load the Chubby master can easily handle, and it's more powerful. That is what they want to highlight here. And so the way the scaling is done, because all these clients can be individual processes or maybe different clients also. So that is what is being said here. And we already have some scaling techniques inbuilt in Chubby, isn't it? So one is about this the minimizing request rate, what it talks about. So okay, so whatever the already the scaling techniques are used is, one is we already have this optimized caching. So we always cache all the data uh, at the client side. So that is the way we do it. So it helps scaling, isn't it? So because we don't allow the read request to go and hit the master always, but we take all the master data and copy cache it in the client. So therefore, that is almost as like you are scaling the read side. Okay, instead of the request hitting the master or the Chubby cell, it is always going and taking it from the local client cache. So that is one thing. And second is they talk about the minimizing keep alive load. So we all know that Chubby uses keep alives, and the keep alives are used for different things also. Like it is used for that event invalidations and many other things. So therefore, it's just not just a keep alive, but it is also way of communication other events. And also with the keep alives, actually what they do is it's not always periodic. It is periodic though, but then what it says, the default value is of 12 seconds. Okay, but then that can be extended to more number of, like maybe if you expand to 60 seconds. So in that case, if you have a heavy load, because you don't want the master to be hit over and over by the keep alive, right? So you can actually increase your release times in that case. So that is again configurable, and that is done by the master. So therefore, that is way actually you can scale the system, because you uh, disallow the keep alives to frequently hit the master. But then again, the third thing what they talk about is the minimize the request rate. And what is said is the Chubby cell will have an arbitrary number of, sorry, the whole Chubby ecosystem will have, they will actually create more Chubby cells. Okay, it's not a single Chubby cell, but there will be more Chubby cells. And so the clients which are actually trying to hit any Chubby cell, they will find the Chubby cell which is closer to them using a DNS. Okay, so that is what, instead of the clients which want to connect to a very remote machine or maybe a very far away machine, and that will introduce some lag and latency. So to avoid that, they create many of these Chubby cells, and they are spread across. So group of clients which are very closer to that, they will go and hit those cells, and the load will be distributed. And the other part what they talk about is protocol conversion. They say that you can use different servers to convert and translate the Chubby protocol to less complex protocol. So like if you want to, that can be done using something like proxies and partitioning, that what we will actually go through it quickly here again. So what they say in this case is, there's another diagram I just copied from somewhere. So yeah, if you look at, this is the Chubby cell over here, we have a master and then we have Chubby cell. And we all know that the master will always take the read and write. But what happens if we actually, delegate all the reads, okay, to a proxy server? So here, if you see there is an external proxy, which is outside of this Chubby, so that will take the hit about all the reads. It will store all the cache over here. So therefore it says that the proxy can reduce the server load by handling the keep alives and the read requests. So the keep alives also don't reach the master, but that will be handled by the proxy. So therefore, the good side will be, but still the read will hit the master. Okay, so sorry, the write will still hit the master, but the read won't hit. Only the write will hit the master. And so if you see now, even if you look at the diagram, what they are saying is this, there will be an increase in number of clients, because if we just add an external proxy, so that will handle more number of clients, because everything is actually done with the proxy. So that is one way of actually, scaling. You use a proxy, and that can be done. So it says proxy allows a significant increase in the number of clients, and if a proxy handles end client, okay, so then you are actually reducing the traffic by a factor of n. So that is what it says. And so proxy cache can reduce the read traffic by at most the mean amount of read sharing. Okay. So this is one thing. And then the last one, what they talk about in the scaling is you can do a partitioning. Okay, so the partitioning is like, because the Chubby always follows those file system interfaces, so you can the interface can be designed such that the namespaces can be partitioned, right, between multi between different Chubby cells. So in this case, so if we see that if a Chubby cell has n partitions, right, so and each and every partition can have a set of replicas of a master and all that. Okay, a set of master replica. So if we have that, and then if we they are partitioned based on the namespace. Like here, there is an example here. If there is a node which is D by C, where we in a directory D, therefore it is D by C, right? So then it will be partitioned. So you will use a hash function, and this hash function will actually hash based on the directory. So, and therefore always whatever those nodes, whatever the file what you want to store in that particular node will hit the same hash or will give you the same output, and therefore it will always lie on the same node. Okay, so that is why if they have given just some example here over here. If you hash with the particular directory and then you mod with the number of partitions, so you'll always get that current node. Okay, and the same thing for the metadata. For the metadata also you can do that, but the metadata, it says that whenever you are hashing, you don't hash with that directory, but you hash with this parent directory. That is what is the D dash, and therefore it will lie on a different partition. And it has to, because it's a metadata of that particular node, right? So it has to be on a different partition. And but if you still see, there will be some cross partition communication. And okay, so why we do this partition based on the namespace of the directories? Because we want to reduce the load. So whenever we have partition, we want all those read or write requests only go to a same partition, and therefore we don't have too much of a clutter of the requests all across the partitions. And so if we are able to segregate those requests to a particular partition, then the load will be very well handled by those partitions. But still they say there will still be some cross partition communication in case like when we have an ACL, because whenever we want to send a open request or we want to delete something, so when we want to open a file, so we always want to actually access the file those permissions, right? So you need that ACL. So at that time, because the ACLs will be stored on different partitions, so you will still need that partition. But also it is said that such things are only done when you're opening a file or when you're closing it, right? So that happens it happens, but it doesn't happen very frequent, because the read and write happens very frequent, isn't it? So therefore, once the file is opened, it will always be cached and it will remain open for a long. And then only when you want to close it, then only you again say and go and access that ACL. So those requests, the ratio, if you compare with the write and the read, along with the accessing the ACL request, they are not so much, and therefore the cross partition in that case is still okay. And also the other time when we want a cross partition communication is when we actually want to delete a directory. So in that case, when we want to delete a directory, we would like to find out if any nodes are still present in the directory. So that also, deleting a directory doesn't happen often. So that also happens rarely, and therefore they say still the cross partition communication, whatever happens with this mechanism is still okay, because the cross partition load is not that much. Okay. And then they have discussed some of the majority of the partitions. If it is large, how it is actually reduces the read and write. And so also, but the last is like partition doesn't necessarily reduce the keep alive traffic, because keep alive traffic will always still go, and it has to, right? Because that is the only way you can communicate from the client to the master. So there are some things, but all the challenges are handled. And there was a statement being said is, even the partitioning mechanism already implemented in place, but it was not activated in those days when this paper was written somewhere, or this information someone got it from 2006. Maybe by this time it's already up and running, but it was just a plan for Google to implement the scaling in this way also. I'm not sure whether they are using it or not, but that was a very interesting thing to know about it, right? So just thought of. Okay, so this is the way the whole thing is, about the scaling. So as we discussed today about caching a database and the scaling. But the caching is the only more important thing if someone wants to actually really understand about this Chubby. Rest of the things they are okay, good to know, but they don't really have much of a difference in what actually it is, because it's very implementation specific. If you look at the database, the mirroring, and the scaling, isn't it? So it's not very generalized somewhere, but if someone really wants to work on hardcore about the Chubby, then only these things are more interesting. So therefore, I just went through it very quickly. Yeah, any questions?
What kind of DBs they might be using this Chubby? Like it's a key value you told, right? So underlying is what? It's a normal file on disk or?
Yeah, that's a good question. There's no mention about anything like that, but
It's not
yeah,
a storage, right? So I mean, it's not a storage system, right, Chubby? But for
Chubby is
storing the
not.
metadata.
You can have a different storage engine. Can be. You can have a different database, maybe key value pair, like a sort of a Cassandra type. Yeah, you can have that, but they have not mentioned like that. Or maybe a file system also, like a GFS, the way you
Yeah,
are
that
saying
is what I
about.
think.
Mhm.
Hmm.
It depends again, maybe based on whatever that Chubby cell is addressing to, because usually they just want to copy small files. So whatever is very easier way for doing. I don't know. Yeah, because I
Yeah,
didn't
I
see
was
anything.
also.
Right, right. I was also trying to see, because if you are not using a Berkeley DB, then what you are using, I was curious to know, but they never said anything about very specific. But maybe they leave it open for others to implement. They don't want you to be restricted only to Berkeley DB. So whenever you think your data store doesn't have any risk of exposing some sensitive things, so then that also can be used. So it's more of a open-ended for others to actually use it. Mhm.
And they use log to have that replication, right? If the master fails, then from log it can recover.
Yes, because we have always have that write head log as well, the snapshotting. So whenever you want to recover it, or you want to bootstrap a new replica, so you always go to that snapshotted place wherever it may be in a JFS file server, and also whatever the current master where we are adding this replica, you will get the write head logs, the whatever the difference is between whatever was on the GFS file server and the current updates. So you still have to go to the master. First, you copy from the GFS file server, and whatever the current write head logs you have on master in that particular cell, you again replicate from that. So that way, that will be used for the disaster recovery as well as for the new replicas.
Yeah, yeah.
Yeah.
Yeah, this makes sense.
Yeah. So there was really not much anything other than this caching, and this caching protocol, even though it is said over here, this is the way the flow is, but there are many questions in this. I also had many of them, and maybe if you read more into it, it is really, we don't know. But on a high level, these are the only what you say, the very highlights how actually this invalidation protocol happens. But I think the way Sri asked that question, what happens, because you see so much of time, it may be sort of a lag there, right? So what really happens? Those things are really not well explained everywhere. But what the way I think about is, it might be very implementation detail, and those things they don't want to really expose, or because in any distributed system, the whatever the objective anyone is handling, or maybe they are actually focusing on. So if that objective in this case is more about, a coordination service, and that also it has to be strictly consistent from the read side also. For that, you will have a trade-off in this case, isn't it? So there might be some latency issues if you want to do that, but that is what it is. So if you want to have a strongly consistent, even using a caching system at the client side, but you still have it, but then there will be a trade-off saying, okay, there will be some lags, some for the some it calls. That is what I would think about. But there are some different questions how everyone handles that, So yeah. But being a Paxos underlying, everyone knows that it's a multi-leader and all those things. Leader election is always an expensive affair, isn't it?
And Paxos takes care of that leader election.
Yeah, and also this whole thing is actually a service. That is what it is. Usually, yeah, maybe whatever service it is, they don't specify whether it's microservice or, but it's like a service. So that is what they started with, right, initially. Yeah. Okay. Yeah.